then that would delineate the distribution of sample means, the complete set of sample means that we could obtain from this population. And if we were to plot that set of sample means, they would be normally distributed. And they would have a mean themselves, the mean of the set of sample means, the mean of the set of sample means. Now, assuming we don't know the mean of the set of sample means, let's take one random sample, mean. Since it is normally distributed, then we know, because of the properties of a normal distribution, that there is a 95% probability that our sample mean is within plus or minus 2 standard deviations of the center of the distribution of sample means, which we don't happen to know. So we know that the center of the distribution of sample means is within plus or minus 2 standard deviations of the results of our sample with a 95% certainty. However, that doesn't tell us very much, because it's really the mean of the population that we're after. Mathematically, it is true that the mean of the sample means is identically equal to the mean of the population. This astounding result is why polling is possible. By taking one poll, we can state, because of the property that the samples are normally distributed, that the result of our single poll is within plus or minus 2 standard deviations of the center of the means of the complete set of samples that could be taken. If it is also true that the center of the distribution of sample means is the center of the population, then we can state that the result of our sample is within plus or minus 2 standard deviations with 95% certainty of the mean of the population. Therefore, it becomes exceedingly important to be able to establish that the mean of the population is equal to the mean of the distribution of sample means. This is what we will do in part 2 of this series.